Hello friends. Not long ago, I did a review of a fanless mini computer based on an Intel N4000 processor, which is perfect as a hardware base for installing the Home Assistant smart home system. It is available under several brands, but hardware-wise, it's the same device. You will find the link to this review and the stores where you can purchase it in the description below the video. In the standard configuration, an EMMC is used as the internal storage, and there is a slot for installing an SSD. Although the device description mentions NVMe, in reality, an M.2 SATA disk is needed. This video demonstrates the process of installing such a disk and includes comparative testing with the internal storage. By the way, for creating this review, I used a video capture device from Ugreen, not only for recording video and screenshots, but also instead of a monitor. You can also find a link to the review in the description. Before we begin, as usual, I ask you to like this video. It will help others who are interested in gadgets and smart home topics find it, and subscribe to my channel if you haven't done so before. Manufacturer, KingSpec. Type, M2 SATA NGFF SSD. Form factor, 2242. Disk capacity, 128 GB. There are models up to 2 TB. Maximum declared speed, average. Read, 550 MB per second. Recording, 450 MB per second. I settled on this manufacturer because I have been using their disks in my other mini PCs for several years, 24/7, without any issues to date. It comes in a branded box, sealed in plastic. No additional tasks other than Home Assistant are planned for it. So I opted for the smallest available volume, 128 GB. Although the difference, for example with 256, is just a few dollars. The 2242 form factor means it has a length of 42 mm and a width of 22 mm. This is due to the structural limitations of the mini PC itself. A full-size model at 80 mm simply won't fit. I would like to remind you that a detailed review can be found via the link in the description, where the process of installing Home Assistant OS is also shown. Therefore, some of the moments shown in it, I will skip in this video. If some PCs can accommodate SSDs of different lengths, especially if there's room for an 80 mm drive, this one only supports 2242. At this point, I got a bit stuck because it turned out that there was no mounting screw in either the mini PC or the SSD package. Fortunately, I found a screw of the right size in my supplies, which I used to secure the disk. To simplify the task, I will be conducting the speed tests on the Linux Ubuntu operating system, the same one used for the initial installation of Home Assistant OS, so there's no need to load or install anything extra. Another advantage of this method is that the system is deployed and booted from a USB flash drive, more details about which can be found in my mini PC review. This allows it to be used without touching the operating system already installed on the internal storage. By default, Windows is installed on the EMMC, which I have replaced with Home Assistant OS. By the way, I took these screenshots and videos using the Ugreen CM630 video capture device, a link to which you can find in the description. Besides, it replaced an external monitor, as I could see everything on the screen of my work computer. So after booting from the flash drive, we see the Ubuntu desktop. We need to go to the program list. Here we need the utilities folder. It may look slightly different in updated versions of Ubuntu, but the essence remains the same. There is a utility program called Disks. Currently, there are 3 physical drives in the system. The one called SD card reader is the internal EMMC storage, where I currently have Home Assistant deployed. The next in the list is the SSD, followed by the flash drive from which Ubuntu is loaded. At the top right, there is a button that opens the disk options menu. Among other things, there is a disk testing option. As you can see, no extra steps are necessary. The same system image needed for installing Home Assistant OS can be used for such a comparative test. We will now conduct several tests to see if there is any benefit to installing the SSD. The standard setting is 100 samples of 10 MB for reading and writing and 1000 for the access time test. Here's what the testing process looks like. Average reading speed is 181.2 megabytes per second. Writing speed is 96.4 megabytes per second. Access time is 0.1 millisecond. Now for the SSD, which has just been installed and not yet partitioned. I start the test with the same parameters. The difference from EMMC is immediately noticeable. The average reading speed is 556.2 megabytes per second, and the writing speed is 505.5 megabytes per second, which is even higher than the stated specifications. Access time is 0.05 millisecond. For the sake of experiment clarity, I'll repeat the test with block sizes 5 times larger, 50 megabytes. For EMMC, the average reading speed is 187.5 megabytes per second, and writing is 98 megabytes per second, slightly higher than in the first test, as it should be. For the SSD, reading is 564.9 megabytes per second, writing 522.9 megabytes per second. Now with block sizes 5 times smaller than standard, 2 megabytes. For EMMC, the average reading speed is 170.3 megabytes per second, and writing is 94.3 megabytes per second, lower as it is harder to accelerate on such small blocks. For the SSD, reading is 532 megabytes per second, slightly below the stated, and writing is 476.3 megabytes per second, still higher than the stated 450 megabytes per second. For those interested in more details, I conducted an additional test displaying data from SMART, the built-in self-diagnostic system. To thoroughly explain each parameter would require another separate lesson, so I'll just say, the disk is in perfect condition. The values correspond to normal. I'll leave the screenshots for those who want to study all the values in detail. The previously installed Home Assistant OS on the EMMC is no longer needed, so I am formatting the disk. I did not make backups, as this is a clean, test installation. If you have a working system, it's better to make one. I will show another possible data transfer method shortly. If you have standard Windows installed, you can leave it untouched. I chose a slow method, filling all available space with zeros. I confirm and wait for the process to complete. Now the EMMC looks just like the SSD. For the SSD, I am loading a fresh version of Home Assistant OS. As a reminder, the entire process is detailed in the review of the mini computer. The link is in the description. But briefly, the downloaded, unpacked, and recorded image on another flash drive needs to be opened using another standard Ubuntu utility, Disk Image Writer. During this process, 4 drives are connected to the mini PC, the EMMC, SSD, and 2 flash drives. There have been no changes in the installation of Home Assistant OS itself, but I decided to briefly show it again for the purpose of reaching another method of transferring data from one internal storage to another. After the writing process is completed and the disk partitioning looks like this, we no longer need Ubuntu. We go to the shutdown menu and select the reboot option. But first, the system will remind you to remove all unnecessary media, in this case, the 2 flash drives, and confirm the reboot by pressing the Enter button. You can enter the BIOS by pressing the F2 key to ensure that the SSD is recognized properly and appears in the list of boot devices. If there's still a system left on the EMMC, make sure that the SSD is set as the priority boot device. The first boot takes longer than usual, but if everything goes smoothly, it ends like this. On this screen, you can see the IP address assigned to the mini computer. The monitor connected to the mini PC is no longer needed, and you can proceed using a browser. Navigate to its address, adding port 8123 at the end with a colon. You will need to wait some time for the system to prepare for its first startup. Next, the process is as I showed in its review. Create a new account, or if you need to restore an old system, specify the path to the backup file and recover from it. During the new installation, the system might detect a number of devices on the network, such as Yeelight lamps, Xiaomi Wi-Fi and Bluetooth gadgets, media players, and so on. This is roughly what happened in my case. Several Xiaomi Bluetooth sensors, Google players, WLED, and Yeelight lamps were added to the system. What I wanted to mention is found in the Settings, System, Storage menu. There is an option there for moving disk data. This allows you to transfer all data from one disk to another. For example, if you, like me, Have Home Assistant OS already installed and configured on the EMMC and you've added an SSD, you can move all the data in this way without loading Ubuntu, reinstalling the system, or restoring from a backup. This method is simpler and faster, and if you want to test the speed of your storage, you can always just boot from a flash drive with the same Ubuntu and check everything without deleting data. As we have seen, installing an SSD allows for a significant increase in read-write speed to the internal storage, which undoubtedly enhances the system's performance. Remember the necessity of creating backups, especially since this process can be automated. You'll find a tutorial about this in the link in the description. And if something happens to your disk, the system can temporarily be deployed on the EMMC, but it's better to have a spare disk on hand. That's all. I hope this video was useful and interesting to you, and I would appreciate your likes as they help with promotion on YouTube. If you don't want to miss new reviews and lessons, subscribe to my channel. In the description, you will find all the necessary links to the store where you can buy such a disk and the mini PC, to other videos relevant to this topic, as well as my Telegram channel, Facebook page, and a group for discussions about smart homes. Thank you for your attention. Until next time, peace to everyone.